Hello, friends, students. Welcome back once again. So this is my second video on digital electronics. And here we are going to study about basic logic gates. In the last video, I have explained you about digital electronics, and we have discussed one gate there, very basic gate there, that is AND gate. So today we will discuss two gates, that is OR gate and NOT gate. OR gate and NOT. Not gate. So let's start with the testing of OR gate. So please remember A plus B, that is the gate looks something like that. That is OR gate looks like this, which have 3 points, 2 input and 1 output. So A plus B, that means whatever you give signal on A and B according to the two triple. Suppose 0, 0, the output will be the Q, that is the output will be 0. If one of them are 1, please remember, one of them are 1, it will be the Q is the output will be high. That is, if A or B is true, A or B is true means that is either this is anything, then this thing will be true. That is, Q will be output will be true. So here in this case, we are getting 3 Q output, high output, we are getting 3. Whenever there is a 0 and 1, 1 and 0, and 1 and 1. So you will get if A and B, both of them are 0, the output will be 0. So what IC we are using here, 74 series, 74 LS32, that IC we are going to test, which has 4 gate inside, and the circuit goes like this. The same circuit I have built. One side here it is given 9 volts. So I've given only 4 volt because this particular IC, that is the latest one, it works from 2 volts to 3 volts also. So please remember that is this gate, that is will work from, that is 74 HC32 series will work from 2 volts to 6 volt, and other it will work from 5 volts. So we have used IC which input is 2 to 6 volt. Okay, so we will see this live. This thing will check our logic outputs. All right. So since we have discussed that, we are also discussing second gate. So let's study about that gate also. So second gate is NOT gate. This particular gate is also known as inverter gate. Okay, please remember. So inverter gate, there is only one input and one output. So as a triangle, you can see A is only one input and output is Q. So please remember the symbolic representation. The truth table is very simple. Here A, you can change 2 states. Either it can be 1 or either it can be 0. That is high or low. So in that case, exactly reverse. That is called as inversion. If 0 is there in the input, then output will be 1. If 1 is there in the input, that is A is equal to A is 1, then output will be 0. So exactly reverse of the input is nothing but we call it the inverter. Q is the opposite of A, right? That is I understand. One more you can see here, we have used 74LS04. So this is the gate, single gate, which has 1, 2, 3, 4, 5, 6 gate inside. That is 7404 series IC. This is our diagram. According to this, we will make it and I will show the output. One more thing you should understand. To understand, we can also use resistor transistor logic. That means 2 resistor, and as an NPN transistor, that we can invert the function. That means when A, that is the input to the base, if it is low, the output will be high. Okay, and if input is high, the output will be low. Okay, so this is with the help of a transistor also we can make it out, and with the help of a IC also. So this 2 gates are, or rather AND gate, OR gate, and NOT gate are very basics of gate that everybody should know. So let's go to the lab and test our gates. Both the gates will test. That is your OR gate and NOT gate. The simple way, the electronics you have to understand, that is digital electronics. The last video already we have discussed. When the supply voltage is given, at that time the light is glowing, we call it as 1. And when it is 0, that is when it is off, we call it as a 0. So 0 and 1 are 2 binary numbers. That is the thing. That is the circuit, simple circuit we have already seen last time. So just for refreshing, I have given you the idea. Now, let's go to our OR gate now. I have arranged the circuit. So I will tell you, this is my 74HC32 IC, this one. Okay. So here already I have shown you in the figure, we have 4 gates here. So we are using only one gate, that is connected to, A is connected to pin number 1, B is connected to pin number 2, and 3 is the output which is connected to your LED. Another end of the LED is going to ground. So this IC, to drive this IC, we need minimum 2 volts to 3 volts. Okay, so I have connected positive end of the battery to the common point, which is going to my switches also, as well as to the supply to the pin number 14. Pin number 7 is ground. So okay, so what is the state now? What I will do is I will just try to show it to you. I will put it on ground here. That is the battery ground, and let's check the switch A. What is it is giving? It is A is 0, B is also 0. Okay, so 0, 0, this is off. Now let's put A to switch. That is, let's put it to A. So let's try it here. It is, okay, some 3 volt is there. This is 0. Okay, so 1, 0, that is 1. Okay, please remember according to truth table. Okay, so this is high. Now we will put this also high. So this is also high now. This is also high now. So both the place at that time, that is 1, A is 1, B is 1, and this is also 1. Okay, right. If both of them are 0, like let's do a switch off this also. So I have switched off this B0, B0. This is 1. So it is coming high. That is 0 or 1 or 0 is 1. Now let's do one thing. Both of them, it should be low. Let's put it off. So this is off 0. This is off 0, right? So at that time, what is the state? It is off only. Please remember that. Okay. So this is the simple working of your what gate? That is OR gate. Okay. So 2 resistor I have used it here, which is to be connected to ground. That is from A and B, 10 kilo ohm resistor. This is a series resistor which is going to the LED. Now let's take the discuss, or let's see the another gate. So these are practical things. Why I'm telling you? Why? Because you should know how actually the gate works. That is the basics of digital electronics. Another IC, that is 74LS04. That is our NOT IC. So please remember, in NOT IC or NOT gate, you have single input and single output because it's a inverter. Okay. So here I have, what I have done is I have given one switch connection to pin number 1, and the output I have taken from pin number 2. And it is another end, it is the LED is connected to ground, same. So all the 74 series ICs, pin number 14 will be supply and pin number 7 is ground. So accordingly, you should remember I've given the battery connection according to that. So let's stay, I will just check what is the output over here. Let's see what is the output. That is, output is 0. That's why the bulb is going reverse. That is 0. That's why it is 1, inversion. Okay. Now let's switch on supply. Okay, so now the supply is there. Let's see, the supply is there. Yes, 3 points, some change has come, and it is 0 over here. So whatever the input is there, exactly the opposite of it, that is nothing but we call it as an inversion, or it is a NOT gate. I hope you understood this circuit. The IC numbers you have to understand. Again, here input I have connected 10 kilo ohm resistor to the supply, from 10 kilo input to the supply. Everywhere you have to please remember 10 kilo ohms. If let it be one input or 2 input, you have to connect this compulsory, this circuit of higher value, this resistor of higher value, that is 10K. Only the thing is, we have used only one switch, that is with the gate, because there is only one input. So this is, I hope you understood. If you understood this, please subscribe, and in the coming days, I will show you the other gates, example with examples. So this few points you should understand. This is very important for digital electronic students. Thanks for watching. See you next time.